All right, now we're going to do something that is slightly more complicated, but honestly, it's almost exactly the same. It wants us to factor completely. And this word completely is really important. The idea is we need to first, if possible, take anything common out. So, all of these we can factor out or divide out a 5. I'm just going to zoom in here. So I can take out a 5, and I'm left with 5 over 5 is 1, so just an x squared. 40 over 5 is 8x. 35 over 5 is 7. And now that you've done that, you can actually factor this. So x squared is going to be x and x. 7 is 7 and 1. But they both need to be negative. Negative 7 times negative 1 still preserves. This is a positive 7. And the left side still preserves to be x squared. My diagonals are a negative 1x and a negative 7x. Negative 1 and negative 7 add up to negative 8. So again, this diagonal is negative 7x. This diagonal is negative 1x, which together add up to negative 8x, which is my middle term. So this is a factor, x minus 7 and x minus 1. X minus 7 and x minus 1. That is now factored. You cannot box this, though, as it stands. I asked you to factor completely. You took out a 5, so we're going to need to add that down in front. Now we have factored this completely. This and this are identical. They are the same, but they're not identical. Obviously, this is factored. They are the same expression, just this is in factored form. If you didn't bring that 5 down, they are no longer the same thing. So just make sure that you have it written like this. Okay, let's take a look at the next one. So, what can come out of all of these? What is something that we can divide this by? So I can divide all of them by 7. So therefore I can factor out a 7. And I've got an x cubed, an x squared, and x. The smallest that I have is an x. So I can take out a 7x. So let's take that out. Let's factor out the 7x. 7 over 7 is 1. x3 over x is an x2 remaining on top. 35 over 7 is going to be a negative 5. There's one more x on top. And 28 over 7 is 4, and the x's cancel out. Therefore, I can now factor this. So the left side needs to multiply to x squared, so x and x. The right side needs to multiply to 4, so you could try 2 and 2. And I need to get a negative in the middle, so I'm going to make these both negative. That way it still preserves positive 4. This diagonal is negative 2x. This diagonal is negative 2x. Negative 2 and negative 2, when you add them, gets negative 4. And that's not what I need. I need a negative 5. So I'm going to change this to go to 4 and 1. Again, I need to make them both negative. Now my diagonal is negative 1x and negative 4x. If I add those, I get a negative 5x. Therefore, my answer is going to be x minus 4, x minus 1, as well as I got to carry that 7x down below. Now you can notice I put that 7x in brackets. You do not need to do that, but you can. This is now considered fully factored. All right, the next one. What can we divide these by? I think 9. And what about x's? x3, x2, x1. So the smallest in all of them is an x1. y2, y2, y2. All right, so I can take a y2. They all have a y2. I can take that out. I can factor it out. I can divide it out. So I've got a 9x y squared. And I'm left with 9 over 9 is 1. x3 over x. There's an x2 left on top. The y squareds cancel. 54 over 9 is going to be 6. X squared over x. There's 1 left on top. The y squareds cancel. And 45 over 9 is 5. The x's both cancel, and the y's both cancel. There, so I can factor that. X and x get me x squared, and I need to get to 5. 5 and 1. And they can both be positive. My inside's positive. So then I get a 1x and a 5x. 1x plus 5x is 6x, and that's exactly what I need. So my final fully factored completely factored expression, 9xy squared, and then I've got the x plus 5 and the x plus 1. Okay, so I'll zoom out here so you can see them all. This is the first time where we had to kind of do an extra step. The difference of squares in the previous video, the perfect squares, those are all kind of done the same. Factoring's done the same, but this is the very first one where we had to do something extra, taking out whatever was common, the greatest common factor.